All right, in this video today, we're going to take a look at how to name hydrocarbons. And we're just going to focus on some simple hydrocarbons. We'll talk about alkanes, alkenes, and alkynes, but we'll look at them being just chains with no branches, just some simple nomenclature for organic compounds here. And there's a few things you need to recognize. And the main thing when you're looking at this naming system is to recognize what the root part of the name is. And the root part of the name, as you'll see here, is the part of the name, so right up in this area, the part of the name that we use that tells us how many carbons there are. So this essentially is telling us how many carbon atoms. So by recognizing what the root name is and how it associates to the number of carbon atoms, we'll know when we look at naming these particular compounds what's going on inside them. So if you see meth in the name, that means 1 carbon. If you see eth, that means 2 carbons. Prop is 3. But is 4. Pent is 5. Hex is 6. Hept is 7. Oct, 8. Non, 9. And dec, 10. Right? You'll notice that a lot of these relate to those prefixes that we've used as you get up into like 5, 6, 8, 9, 10 in previous naming systems. But with our organic, these are the root part of the name, and this is what we're going to build our hydrocarbon from. This name is going to tell us how many carbons are in that chain, right? And then remember that we learned that if it's an alkane, right? So alkanes have to have ane in the ending. Alkenes, the ones with the double bond, have ene in the ending, and alkynes have to end in ine. So from our root part of the name, to tell us how the carbons are bonded together, that's where we'll look to put ane, ene, or ine, right? So that's sort of the key part there. And then the other part that we'll get into with double bonds and triple bonds is that we also include a number to tell you where they're located on the hydrocarbon chain. Okay, so that's sort of the general gist of how this is going to work. And so let's start with an example here. So if we look at our first example, we've got 1, 2, 3, 4, 5, 6 carbons. And I'm just going to sort of mark this in red here when we look at it. So we've got our 1, 2, 3, 4, 5, 6 carbons. So sometimes I like to identify where my longest chain is. So I'm just going to put a red loop around it. So I know there's my long chain. It's got 6 carbons. So when I look at my 6 carbons, that means I have to use the root hex, right? So this is going to be a hex. And because they're all single bonded, I know that it's going to end in ane. So we're going to call this hexane. And that's the name of that particular structure, right? If we look at another example where we've used the condensed diagram instead of the complete expanded structural one, as in the previous example, we can do the same thing. We identify where our long chain is. So from our carbon, there's 1, 2, 3, 4, 5, 6, and 7. So we've got 7 carbons involved here. So 7 we recognize as hept. So I know this is going to be hept. And then because it's all single bonds between the carbons, we're going to call this heptane, right? So there's how we name our alkanes. Very easy. Identify the long chain. And remember, the chain could bend, right? Think about just laying out a chain. It doesn't have to be straight in line. It could curve and go around. So sometimes you might see them curve like that, like where a part of it's going up or down. That's okay, as long as you're still following one path. We want to identify that longest chain, count how many carbons are there. That's going to tell us which root part of the name to use. And because they're all single bonded, we know we would finish it with our ane ending there, right? So that's our alkane. Let's take a look at an example of an alkene. So remember, an alkene means we're going to have a double bond, right? So we've got a double bond in our compound. I think in this case, I'm going to use purple here to identify them. So same approach. We want to identify the long chain that has that alkene in it, that double bond in it. So if we look at this example, here's our chain of carbons. We've got the double bond located right here. So we'll deal with that in just a second, but let's count our carbons. 1, 2, 3, 4, 5, 6, 7. So that's again a hept. Remember, 7 was hept for our root name. We can see it right there. And we've got our hept. We've got the fact that there's a double bond, so we want to make the ending "ene," right? So "ene" tells me that there's a double bond present. And then the other piece of information that I need is the location of where that double bond starts, right? So I want to include the number on what carbon that double bond starts. And I always want the number to be from the smallest number possible. So count from the side where it takes less carbons to get there. So if I count from the left side, the carbon double bond starts on carbon 3. If I were to count from the right side, it starts on carbon 4. So I want to make sure I'm going from the shortest side to get the smallest number for where that double bond is. So this is going to be 3-heptene. And you'll notice that we separate numbers from the words of the name using a dash. That's common in organic chemistry, that we will use a dash to separate numbers from letters. Okay, so that's sort of our separator there. So when we name this, it's called 3-heptene. So the 3 tells me at carbon 3 on my 7-carbon chain, there's a double bond. Okay, that's how we name that hydrocarbon. Let's look at this next example. This next example has 4 carbons. So let's look back at our root. Our root for 4 carbons is bute. We can see it right there. We've got bute right in there. All right, so we've got 4 carbons. There's our bute. And when we look at this particular structure, we know this is going to be a bute. We see the double bond present, so it's a butene. And then the other piece of information we need is the location of the double bond. Where does the double bond start? So carbon 1, 2, 3 if I count from the left, or it starts on carbon 1 if I count from the right. So in this case, I'm going to count from the right, and I'm going to call it 1-butene. Okay, so my little reminder, double bond gets counted to give lowest number. Okay. So we count from the right side on this molecule. We're going to get 1 on my carbon 1 of my 4-carbon chain is that double bond. So carbon 1 of my 4-carbon chain is right here, and that's where my double bond starts. All right, so that's alkanes and alkenes. The last example we talked about were alkynes. And if you remember alkynes, alkynes have a triple bond. So in their structure, you're going to see a triple bond between carbons. And when we see that triple bond, we know our ending has to name, the ending of our root name has to be YNE. But again, we're still using our same root names, meth, eth, prop, bute, pent, hex, hept, oct, none, dec, right? Those are going to tell us how many carbons are present. So let's try an example down here. We've got 1, 2, 3, 4, 5 carbons, right? So there's my chain. Again, I'll identify it. I'll go back to red here. I've got my 5-carbon chain. And 5-carbon, if you remember looking back, is pent. Okay. And because there's a triple bond, I'm going to put in the YNE, right? So that part of the name goes in at the end, pentyne. And just like double bonds, we want to number it to tell us where the triple bond is located in the chain. So if I count from the left side, it would start at carbon 2. If I count from the right side, it would start at carbon 3. So again, I want the lowest number possible. So this is going to be 2-pentyne. So at carbon 2 is the triple bond on my 5-carbon hydrocarbon. So 1, 2, 3, 4, 5. At carbon 2 is my triple bond. Let's try this last example. You'll notice in this one we've got a pretty long chain, and it keeps going, right? It goes up, way up this way. So we've got our long chain right here. 1, 2, 3, 4, 5, 6, 7, 8 carbons. So again, looking back at my list, 8 is oct, right? Like octopus. So 8 carbons we've got, so that's oct. And then we want to identify, is there a double triple bond present? There's a triple bond right there, right? So right there is my triple bond. So we know it's going to be octyne. The last thing we want to do is say where that triple bond starts. So if I count carbon 1, 2, 3, 4. So from the left side, it starts at number 4. If I count from the right side, 1, 2, 3, 4. So this one, it didn't matter which side I count from. It starts on carbon 4, so we're going to call it 4-octine. Okay. So remember, just like our double bonds, triple bonds, get the lowest number possible. For their starting position, right? So we always want that lowest number for the starting position. So this is our naming some simple hydrocarbons: alkenes, alkynes, and alkanes, right? Those three particular types. And that should be good to get us started here in this process of how to name these particular structures.